Welcome back to lesson 8, and in this lesson we're going to be learning the basics of mathematics. You might think, well, it can't be that difficult, the simple stuff: addition, subtraction, multiplication, and of course division. Now you would think computers, with all their power, this should be no problem, but as you will see in these lessons, there are some problems to watch out for. So without any further messing around, let's get straight into the code window. So to save some time, because you really don't want to watch me typing in the header information and various other bits, created my sketch mathematics version 1, and we're all ready to go. As usual, it's going to print out the name of the file at the beginning of into the serial monitor, just so that I always know which version I'm working on. Now, in this particular sketch, we're going to look at a few things. First, we're going to look at, obviously, how to add some numbers up. It can't be that hard. My 5-year-old granddaughter was around today and she manages to add some numbers up. How difficult can it be for a computer? As we shall see, there are some interesting points to note. We're also going to look, as part of this, as how to make something run once in the main loop. This is quite an important little step to learn, because there are times when we don't want things running endlessly. And again, in this lesson, you will see the importance of commenting code, because I'm going to be putting a lot of comments in. And one of the issues we will look at later on in this lesson is how integers can overrun with addition. So first of all, let's go to the main loop. Now, normally when we have our setup, this is what runs once at the beginning, and then here we have the main loop. There's nothing really new in here. We've got an if statement. If q is smaller than 1, then we want it to do something. Now, we've defined the variable q as an integer, so it will start with a value of 0. So when this if statement first runs, q will equal 0. That is smaller than 1, so it will deal with the contents of the if statement. Now, what I've done here is put q++ in, which means add 1 to the value of q, so the if statement will fail next time round, because next time round, because q equals 1, it's no longer smaller than 1. Therefore, although the program will be racing round in circles, it will not implement this if statement. Now, you might think, what's the point of that? Well, very often in a programming environment, you may want something to happen only at certain times. You don't want it to be going on continuously. So very often you can put an if statement, and it's almost like a guard for this bit of code. So we might have a lot of things happening, and when something happens, we'll suddenly say, right, q now equals 0, and the if statement will run once, and then because q is incremented by 1, that if statement stops running. So that's quite a common way of using our code, and using an if statement as a way of just making something run once. Now, quick run through the bit of code here. We've got serial print, q equals, that's a text string, and then serial print line q, it will print the value of q. And then it's going to put serial print line simple addition, just so we know what this example is about. And then we're going to use my other integer, w, and it's going to use a for statement now. Now, we've done that before in our control structures. So for the value of w equals 0, w is smaller than 10, w++, so we're going to increment w by 1 each time. And then what I've done is I've created another integer called my answer, and my answer is going to equal w plus q. So we're going to take the value of q, which by the time the if statement runs will be worth 1, and we're going to add it to the value of w, which is going to vary between 0 and 9. Let's compile the code. So the code has compiled up. I'll turn the timestamp off for the next run, and let's see what we've got. So we've got the file name as printed, q equals 1 because that's what that is, simple addition, that's what that is, and then for w equals 0 through to w equals 9, my answer is w plus 1 equals, and lo and behold, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My goodness, this Arduino can count to 10. My granddaughter will be relieved. So we look at that and we think, okay, that's easy, it's all working. So I'm going to stop there. I'm going to load up the next bit of script, and we'll see what comes next. So I've just marked up our example 1, and I'm going to leave example 1 in while I've added example 2. Now, if you remember when we looked at numeric variables, I mentioned about the fact that there is a limit to the size of the variable. If you remember our digital parking spaces and what happens if we go over the value. So this is one of the first things we have to think about. We're now going to look at the problem of overflowing the variable. So this time, instead of q starting with the value of 1, I'm starting the second example with a q with a value of 32,760. The rest of the code is all the same. Got to find a way to compile faster. There we go. Our answer is up. So there's our initial example. Now in my second example, we've got simple addition again, the problem of overflowing. So this time q starts off with the value of 32,760. We add 1, 2, 3, 4, 5, 6, 7, and then notice what happens here. We've overflowed the value and we've gone straight back to the minus value. Now if you can't remember why that happens, check back into the lesson on integers and how they work. But as you can see, if we overflow the value of the integer, we then finish up with the number going minus. And this is just something to keep in mind, because very often you can finish up with an error in your code where numbers aren't adding up to what you expect, and it's actually because you've overflowed the value of the data type that you're using. So let's step straight into our next example to see how we deal with that problem. So I've pasted in the next bit of code, and what we're going to do this time, if you remember, the next size of data type up that we regularly use from a integer was a long. So in our previous code, my answer was an integer. This time I've introduced a new variable, my long answer. And if you remember, a long can take numbers up to, let's check, go to the reference. Any trouble with screens, they jump up all over the place. So let's look at our variable types. Again, the manual is always our friend. Let's go to long, and this time we can have a value up to 2 billion plus change. So I think we're going to have enough room in there. So what I've done, we're going to have exactly the same piece of code that we had before, except this time we're going to add W to Q, and instead of using an integer, we're going to put the answer in a long. So let's compile this and see what we get. Hopefully you'll be having a guess at what you think the results are going to be. Now you can see if you're right. So there's our previous answers where suddenly it went minus, and this time, hang on, we're using a long, so why has it still gone minus? Well, the answer lies over here in the fact that W and Q are both integers. So when the Arduino adds the values together, they're still a simple int, an integer, and so the front of the car has been chopped off, if you remember our digital parking spaces in lesson 6, before it's put into my long answer. So the question we've now got is, how on earth do we get these two numbers to add up and get the correct answer into our value that is now a long? So I'm going to stop the screen and load up the answer for you. So I've just loaded up the new example. So this is our previous example. My long answer equals W plus Q, which were both integers. What we're going to do now, the only change to the code that's been made, is my long answer equals long W plus long Q. Now, if we go to our reference, just so you know where to find this, so we've got data types where we have the ones we're using today, we're using an integer and we're using a long. But if we go down here, we have conversion types. And so what we're doing here is we're using the conversion type long. And the difference is, if you notice, there is the brackets where you put your value inside. And so what it does is whatever value you put in there, it will turn it into the data type of a long. So now that we see that my long answer equals the long version of W, so W, the integer, is now turned into W, the long, and again Q, the integer, is turned into Q, the long, and now when we run our example, hopefully we're going to get the right answer. So there we go. This is our previous version where we got the minus value. Now, as we see, we now get the correct version because we're now using a long. When it gets to 32,767, it just keeps going because we're way below the 4 billion mark. So it just keeps on going. So just an important lesson to learn when you're trying to do even basic addition with your Arduino, when you're doing addition with C++, using any type of, we could be programming a desktop, but obviously we're on an Arduino. But it's one of those things just to realize that if your data type, if you overflow your data type, you will not get the result that you expected. So just be aware, and you'll notice there's a lot of comments in this code, and when you're doing some mathematics, it's always worth having the comments in your code so that you can check that the answers you're getting are the answers you expected. I had someone recently who was complaining that their particular piece of code was all falling apart, and what they were doing was running a code for quite a long time, a number of days, and what was actually happening in the background is they hadn't checked this sort of thing, and one of their values was overflowing, suddenly going back to 0, and of course that upset the rest of his program in a big way. So I hope this first section on addition has been useful, and as you can see, there are the syntax for doing addition is very simple, but there are just some things that we need to watch out for as we progress. So what I'm going to do now is swap the screen over, and we're going to do our next example, which will be subtraction. Right, I've loaded up the code and saved as a new version, mathematics version 2. Quick look through the code. We've got q is equal to 1 as we've had before. Print the value of q, prints out on those two lines. Obviously print what we're going to do, simple subtraction. And then for w equals 0, w is smaller than 10, we're going to have my answer, which is an integer, everything's an integer. And all we're going to do is subtract the value of q from w. That sounds pretty easy considering that q is 1. Now you'll notice down here that I've also got another line where q equals 1. This is because in some of the later examples I'm going to change the value of q, and I need to make sure that q is always equal to 1, otherwise the if statement will just keep running. Now, to save your boredom of watching the code compile, I've already compiled it and run it. So q is equal to 1. That's what we would expect it to put in. Simple subtraction, and here's our answers. So if q equals 1 and our answer is w minus q, if w is 0 and we subtract 1 from it, we get minus 1. Don't forget this is an int, so it can go minus as well as positive. And then as we see, as the number increases, we see the value of our answer increasing in increments of 1. Okay, let's get on to the next example. So, example 2, exactly the same code as we had in example 1. The only difference is this time we're starting off with q equals minus 10. So all we're going to do is subtract minus 10 from w. Let's quickly compile that up. As you can sit there and you can guess what the results are going to be. Hopefully, if you're good at maths, you've got it right. Now, you'll notice that if q equals minus 10, if you subtract minus 10 from 0, you finish up with plus 10. And that's because, as it says at the beginning, if you've got a double negative, it becomes a positive. So minus a minus number is a plus. Simple mathematics. Hope you would have learnt that one at school, but I've put it in there just as an example of how easy it is to have some code that you think you know what the answer is going to be, but you can very easily make a mistake. So that was just a simple bit of mathematics, but it just shows how things can go wrong. Okay, I'm going to skip to the next example. If you're wondering why I'm going so quick, I've got quite a lot of examples to do, and most of these are very simple, so if you get stuck on them, just work through them again, and don't forget all the code examples will all be on the Digital Town webpage if you want to download them or just read them again. Okay, here's our next example, and in example 3 we're going to be subtracting from a negative number. So again, q is minus 10. This time though, instead of q is being subtracted from w as we did up here, we're going to have w is subtracted from q. So we're going to start off with a value of minus 10. we're going to subtract a number between 0 and 9, which is less than 10, and our answers will be, as we can see over here, I've already compiled the code to save time, so minus 10 minus 0 is still minus 10. Minus 10 minus 1 is minus 11, and on we go. Simple mathematics, but it just goes to show this time there's no double negative, so we get the answer that we want. So let's quickly skip on to our next example. So as you can see, example 4, the big change. This time Q is starting at minus 32,760, and again we're just going to be subtracting W from it one by one. And again, I've already compiled it, so you don't have to wait while it goes through all that. And the answers, if you remember back when we've looked at values overrunning, we start off at 32,760, we subtract one, another one, another one, another one, another one, another one, another one, and all of a sudden our value goes from negative minus 32,768 to positive 32,767. So in this example we've overrun the limit of our integer in a negative direction. Again, I've just shown you this just as a quick example of one of the things that can go wrong with subtraction. Now you'll notice that with subtraction I haven't worried about changing data types. The reason being that if we are subtracting numbers, we are not going to outgrow our data type because our number is always getting smaller. So overrunning your data type is not such a big deal, apart from the fact that you can go negative to the point that you can overrun in that direction. So the same rules apply positive as negative. So if we really wanted to do this, we could use a long, and then it would allow us to go to minus 4 billion. But as we've already covered that basic scenario in the previous lesson, I'm not going to include it in this one. So we're going to finish looking at subtraction, and we're going to move on to multiplication. Right, here we are with mathematics version 3. Obviously we're going to be dealing with multiplication, and one of the big things we're going to watch out for during this is how we can get very unexpected results with multiplication. So we've got 4 different types of variable this time. We've seen them all before when we were looking at addition. We've got an integer Q, an integer W, an integer my answer, and there's going to be a long my long answer. So whiz down to our code, and very simple example to start with. Q is going to be equal to 1. So for those of you who know your 1 times table, we're going to go from W equals 0 to W equals 9, which is less than 10, and over on the right hand side we've already got my answers. So Q equals 1, we're doing simple multiplication, so 1 times 0 equals 0, 1 times 1 equals 1, 1 times 2 equals 2, and you can figure the rest out for yourself. The syntax that we use, if you can see here, we have this star symbol, and that is the symbol for multiplication when we're programming in C++. So again, very basic example, but I think you should get the picture after the previous examples. Okay, this lesson I've put in 2 examples just to speed things up. What I've decided to do, we're going to use the value of Q equals 32,760. Now that is very, very close to the maximum value of an integer, and as you will see over here, what happens is that as we multiply it by different numbers, we see 1 minute it's positive, then it's negative, then it's positive, then it's negative, then it's positive, then it's negative. And it could leave you, if you ever get a situation like this, you can start to scratch your head and start to think, what's going on? Well, it's quite simple. We've got a value that when we multiply it by 2 means it exceeds the value of the integer type and the number becomes negative. However, when we multiply it by 3, the number becomes so big that it goes past positive, past negative, and back to positive again. And the same by 4, it goes negative, by 5 it goes positive, by 6 negative, and so on. So that is an example. If you see that sort of weird pattern occurring in your code, then you'll know that you're overrunning your data type. Now, what I've also done just at the bottom is to do a replication of what we did with addition, where I've changed the 2 values to a long, and when we change the 2 values to a long, we get our correct answer. So as you can see, those are the basics of multiplication. And now, without messing about, let's get on to our last one for today, which is going to be division. Okay, here we go with our division. Now, I must admit, when I was at school, I didn't mind addition and subtraction, wasn't too bothered about multiplication, but division used to cause me some problems. And division also, for computers, as we'll see, also has some interesting problems that we have to solve. Now, the symbol for division is that one there. It's a /. Don't confuse it with using the character twice, which is what we use to comment out a line of code. So in these examples, we're going to do the same thing. We've got a value of q, which q++, it was 0, it's now 1. If you wonder why I keep swapping between this and putting in q equals 1, it's just as a constant reminder for you to see the code written in different ways. One of them is where 1 is being added to a value of 0. The other one is where we are stating that we are making q equal 1. So as usual, we're going to go through our 0 to 9, because 9 is less than 10, but not 10. And we shall get our answers, which I've put out over here already to save us time. And as we can see, if you divide nothing by q, you get nothing. If you divide 1 by 1, you get 1. 2 by 1, you get 2. All of those answers are exactly as you would expect, doing some very, very simple division. So let's crack on with the next example. So in this example, the big changes that I've made, we're going to have a value of q that equals 10, because in our last example, because q was equal to 1, our answers were always going to be a whole number. But when I was at school, the big problem with division was fractions, or if we're working in decimal, numbers that are behind the decimal point. So I've already run this code, the differences. So the other thing I've done here, w, instead of start, is going to still start at 0, but it's going to be until it goes to less than 31. So it's going up to a value of 30. I wanted to do that because, as you'll see, it'll give you a little bit better idea of what is going on. So as we look at our results, we see that w, 0 divided by q, so 0 divided by 10 is always going to be 0. But now we've got a thing where 1 divided by 10 equals 0, 2 divided by 10 equals 0, and on it goes until we get to 10, and then 10 divided by 10 equals 1, but 11 divided by 10 also equals 1. Now, if you're good at your maths, what you will realize is that the values, all the results, are being rounded down, and that's why I've put it in the text at the top. And that's why I went up to a value of 30 so that you could see that 30 divided by 10 equals 3. Now that can be a big problem for us. There are times when we wouldn't be too worried about what went on behind the decimal point. So for instance, when we look at building the robot car, if you want to follow that, there'll be an example on using a ultrasonic distance sensor, and on that one we will be seeing sort of how many millimeters something is in front of the vehicle. So we don't mind in that situation if it's rounded down to 1 millimeter. We just don't care. But if you imagine if you were an aeroplane coming into land and the distances it was using was in meters, you certainly would be interested in getting it right, because all of a sudden you could hit the floor quite hard. So we're going to now look at how do we get more exact answers using division. Well, the first solution to our rounding problem might seem a very weird one, but it is actually one that's used by programmers quite a lot. And if you look here, all I've changed is my answer, which is still an integer. Instead of being w divided by q, is w times 100 divided by q. Now you might think, why has he done that? Well, actually, by multiplying w by 100, the results we get as I scroll down the serial monitor, because I've already compiled the code, is that we now see a set of values 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. So we're seeing all the values, but that because we've multiplied by 100. Now there are times where this is a very, very useful method of avoiding using numbers with a decimal point in them. If you can use this method and get away with it, depending on obviously what you're doing with your code, you will actually save your Arduino a lot of processing time. Because one of the issues that happens is, just like my brain gets confused when I've got to use fractions or numbers with a decimal point, so too for computers and calculators and an Arduino, they also have their little struggles. So one of the solutions that you can have is to multiply your number by 100. Sometimes you might even multiply by 1,000 if you wanted to get, that extra idea of a third decimal point. But this is a very, very simple solution as to how to get around the rounding problem and still use integers all the time. So that's a simple version. Now let's get on to the more complicated version. So in this bit of code, I've gone back to the code we had earlier where we simply divided w by q. And that's what we've got here in example 4. The only difference is here, instead of w by q, the answer being as an integer, it's going to be my float. Now a float, and I've declared this at the top of my page, that's the syntax for the variable type of a float. A float is a number that has a decimal point in it. So what we're going to do now, w divided by q, we know that has fractions in it, numbers after the decimal point. So I've compiled the code in advance for you to see, and this is the results that I get. Disaster. So I'm not getting the fractions after the decimal point that I would require. How this should look, if we think about it, if that's 10, 20, 30, 40, 50, 60, 70, 80, 90, and they're multiplied by 100, what we would expect here is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. But we don't get it, and it's exactly the same problem that we had earlier when we were trying to take two integers and turn them into a long. The two integers, one is divided by the other, and because they're now rounded down, when it goes as a float, it just takes the already rounded down number as the value of the float. So we get the rounded value rather than the value that we want. So I've quickly changed the code. So this was our previous one, my float equals W divided by Q, and all we've done now is my float equals the float of W divided by the float of Q. And again, if we look in our reference, this is a conversion, and there is our conversion. So it converts any number to a float, which is a number that has a decimal point in it. So now when we run this code, it takes two numbers with decimal points in them and it changes them to a and the result comes out as a number with a decimal point. And I've compiled the code so that you can see the result. So this is what happens if we don't use them as floats. As soon as we put the number as a float, we get the results that we would want. Now, one thing you will notice is that it prints to 2 decimal points. Now you might think, well, what happens if I want a number that goes to more than 2 decimal points? So what we're going to do, I'm just going to put an example in here just to show you how that is done. And we go my float to 4 decimal points, because actually in the background our value my float does go to 4 decimal points, but the problem is that when we serial print it defaults to 2 decimal points, 2 values after the decimal point. So the code that we use is just to change that value there. So if we put this number in here, that will give us to 4 decimal points. I'll quickly compile that and run it. It says waiting patiently. There it is, whizzing through all our examples. We get down to the bottom. So now we've got the value of 2.8, and then it says to 4 decimal points we see the full value there. Now, one thing to be aware of with division, no matter how many decimal points you go to, there will always be some rounding off. And so you need to be very, very careful if you divide one number by another number and then multiply it back by the first number, which for those of us, when we're at school, we would expect the start value to be the same as the end value. You will actually find that the start and the end value can be slightly different due to the rounding off of numbers. So just be aware of that and think about it in your code. I'm sorry this has been a bit of a fast lesson, but it's been quite a lot to get through and you might have to go through it a couple of times. But I wanted to get all this information in because if you're following the robot car tutorials, we will be using things like a float at times. We will certainly be using multiplication, division, addition, subtraction. That's all standard parts of programming. So it's actually quite important that we get our heads around this early on. So let's think about what we've actually done during this lesson. We've dealt with addition, we've dealt with subtraction, multiplication, division. We've looked at the problems that we've got to look out for. Other things that we've learned to use a float for the first time. And we've also seen how to make something loop only once in the main loop. So all of these things will be useful in future lessons, But I hope you've enjoyed that, and I know it's a lot to get your head round, but you begin to see now also why commenting code is so important, because just examples like this help you to see where errors are starting to spring up. So thanks for watching, and the usual thing, if you enjoyed it, click the like and subscribe. Thanks again.